Welcome, everyone. It is such a pleasure to see you. If this is your first time, for a couple of semesters now, we have, instead of doing a talk here or there that like, oh, right, there's one on Thursday, or oh, there's one, the second Tuesday of the month or whatever, we've had a weekly series through cultural affairs at a number of organizations. So I'd like to give a shout out to Dorothy Chef from Cultural Affairs. Her great work helps to put this together. And we will have a series this um, semester with some of the same talks I've given before, a bunch of new ones. You're welcome to attend online. We'll use the same Zoom each week, and you're welcome to attend in person in the Rally Building 128. So we would love to see you. I mentioned cultural affairs, but I'd also like to mention that there's a whole bunch of great organizations in our area that are interested in wildlife and birds. And I just want to give a shout out because I don't know who to talk about because I'm a member of all of these organizations. So there's the Orange County Audubon Society. We do a lot of work with them, and a lot of the images come from the sanctuaries that they maintain. I'm showing you this because if you say, "Ooh, this is of interest to me," like these are seem to be my people, then all of them have websites which list their presentations or upcoming field trips. There's a Bashakil Area Association protecting that important wetland. Oh, and there's so many more. There's the Sullivan County Audubon Society, the Edgar Mearns Bird Club. There's a Friends of the Shawangunk Grasslands. There's a Friends of the Wallkill River in Pennsylvania. There's the Gifford Pinchot Audubon Society. So if this is a topic which interests you, then you have people, and they would love you to join or to go with them on their various outings, etc. Tonight, I'd like to talk about climate change and do it slightly differently than I have in the past, a little less on the climate physics and a little more on how it affects wildlife at the end. But I hope to treat a whole breadth of topics. And if anyone says, "Ooh, that was interesting," I'd love to go back and see that little video. Then I welcome you to visit my YouTube channel at Dr. Jan 41, DRJAHN. That's where all of these videos live. And I'll also record all of these. So if you ever have to miss one, etc., then you can always get caught up. Okay, so it is January, and this is a great time of year to talk about climate change because all of the statistics from last year just came out. So we can talk about where the year 2025 ranks in, annual temperature. However, maybe it's also a little difficult to talk about global warming because January in, where we live in the Northeast US is this is one of the coldest times of the year. And I just like to stress the difference between weather and climate. So it was cold and
Right.
snowy outside my window today. This is from today, and I'm sure you had the same. We're not in person because of the snow cancellation. But what we are concerned about is not weather, but climate. All right. So as I'll get to in a few minutes, last year was the third hottest year since we began measuring global temperature. So there is a trend here. That is climate, not weather. And just a little bit more on the differences. Um, the end of December, beginning of January was really cold. Look at the Delaware River. It's practically frozen. But then by middle January, I was kayaking on the Delaware at least a little bit. Look, it's ice free. That's weird for the middle of January. I saw this rare duck I'd never seen before. That was really cool. But then, as you know, it got cold again at the end of January. We could say, ooh, this January is pretty cold. Last January was pretty warm, and the ski slopes, they were limiting the access to the number of slopes which were open because of how much melt had gone down, had happened. There are some winters where everything is frozen, and there are sometimes in the middle of January, the middle of February, you've got open water at these wetlands. All right, so we could go on and say, ooh, this February, the this ski slope was really um, warm or whatever. But once again, this is weather, not climate. And so we'd like to focus on climate today. All right. So, January 2026 was cooler than the rest of the US, but globally it's warmer. And so, this is whether we want to talk about the long-term trends. And key to this is how much heat stays around planet Earth. And I want to talk about greenhouse gases. And I want to start perhaps in a weird way. I love greenhouse gases. Love them, love them, love them. And I'm sure you do too. Because if the temperature of Earth, or like any planet, like Venus too, was determined just by its distance from the sun, it would be
Yeah.
freezing. The average temperature on our planet would be minus 18 degrees Celsius. There would be no oceans. There would be no lakes. There would be no Delaware River, Hudson River. There would be no liquid water. But that's not the temperature. Our actual temperature, and if you wouldn't mind, I'll try to do it as best ooh, don't do this again. Oh, don't, oh, stop. Okay, I'm sorry. I'll stop trying to play with technology and act like I'm sorry. Um, so the reason that our planet is much warmer than this is because there are gases in the atmosphere which trap heat. So energy comes from the sun, and instead of dissipating back into space, a lot of it gets trapped because there are gases in the atmosphere which absorb it and it prevent it from going out into space. Now, this is something that's familiar to us, all right? Because, for example, if you're wearing a green shirt, it's because this shirt absorbs blue light and absorb red light, but green light bounces off. If you're wearing a blue shirt, same, a similar thing. So molecules absorb certain wavelengths of energy and they reflect others. Heat is a form of energy. So just like light is a form of electromagnetic energy bouncing off of objects, so is heat. And just like there are molecules which can absorb green or can absorb blue, there are molecules which can absorb infrared, which is heat. So if this is heat that's leaving Earth and going up into the atmosphere, and we can measure it from 2 wavelengths to 17 wavelengths, I'm sorry, microns to 17 microns as its wavelength. There are certain molecules which will absorb certain wavelengths, just like there are molecules in shirts which would absorb green light or red light or blue light or whatever. Carbon dioxide absorbs heat. All right, so this is a fact. There are certain wavelengths that it absorbs. So the more carbon dioxide there is in the atmosphere, the more heat the atmosphere will absorb. That is not in question. Methane absorbs heat, and we can measure it absorbs this wavelength of heat. It absorbs this wavelength. Nitrous oxide does as well. So these are gases which absorb heat in the atmosphere. And part of me is very happy about that because our planet would be way too cold if the atmosphere didn't absorb heat. The problem is we humans, through our activity, we are changing the amount of these heat trapping gases. We are making more and more. So this year, there is more heat trapping gas in the atmosphere than there was last year. And there was more last year than the year before. This is measured every year. Every year, scientists are diligently measuring the amount of carbon dioxide. And if you notice, it has continually gone up. So if I were to tell you that the year 2025, which just ended, that's the last year where we have data. Obviously, we don't have data for 2026 yet. The year 2025 had a record amount of carbon dioxide in the atmosphere. So when we started measuring it at around 1960, notice the parts per million were 315. So more than a quarter of the carbon dioxide in the atmosphere of the entire planet is new since 1960. This is because of the fossil fuels that humans burn, et cetera. All right. So as you look at, all of the, people here, they need energy. So the electricity that they generate is releasing carbon dioxide. The cars that they drive release carbon dioxide. They cut down trees, that releases carbon dioxide. So now there's more heat trapping carbon dioxide in the atmosphere than was before. And the same applies to methane. Now, you might say, oh, who cares about methane? There's not as much of that. But 1 kilogram of methane absorbs as much heat as 34 kilograms of carbon dioxide. It has something called a greater global warming potential. So even though there's not as much of methane in the atmosphere, it's still a significant contributor to the temperature of the planet. Nitrous oxide, there's less of that, but it's more powerful. A kilogram of that absorbs as much heat as 300 kilograms of carbon dioxide. And there are more molecules, including one called sulfur hexafluoride, that absorbs 32,000 times as much as the equivalent weight of carbon dioxide. Not only is carbon dioxide going up and up and up, so is methane. Look, every year is a record. So, and I apologize, this is actually a little boring because if I were to say last year was a record level of methane, you could say, well, sure. All right. The year before it was a record level. The year before that was a record level. The levels just keep going up and up and up. And the same is true of nitrous oxide. Every year we hit a record. The same is true of sulfur hexafluoride. Every year we hit a record. Why? Well, in large part because there are just more and more people. When I was born, all right, there were about 3.5 billion people on the planet. All right, the planet reached 1 billion people in the year 1800. It reached 2 billion in 1928. When I was born in 1966, it was around 3.5 billion. But if we were to ask now, as 2026 begins, I'll get to the end of this graph in a second.
Oh, good.
We are now at 8.3 billion. Now notice, like I'm old, but I'm not that old, certainly not geologically speaking. My lifetime is just a blip in the history of a planet. But global population and the human species has been around for over 200,000 years. But in my lifetime, global population has more than doubled, going from 3.5 billion now to 8.3. So as there are more and more people, this is the reason why we're producing more and more of these heat trapping gases. So there is no question. Every year we are hitting record levels of heat trapping gases. So it shouldn't be a surprise if our planet gets warmer. There are more and more heat trapping gases in the atmosphere and more people which are producing these gases. Now, to be fair, not everyone produces the same amount of this. So if you wanted to have contests, and I don't, all right, but if you just wanted to say which countries release most of these heat trapping gases, let's take carbon dioxide. China, all right, releases more than the United States. The United States releases more than India, et cetera. So we could list this. And some countries are contributing to this more so than others. But in addition to total amount, you could ask, well, what's the per capita increase? Like how much is each person producing in these countries? And even though as a country, China produces more than the United States, per capita, the United States is releasing more than China, and you can see the variations there. Okay. But the point is, because heat trapping gases go up, the temperature is going up. So we can focus on this year versus that year, and I will talk about, how 2025 ranked. But in general, this is the important graph because here's a yellow line that represents, well, let's call it a baseline and an average. So from the year 1900 to the year 2000, 100 years, all right, temperature was measured. So let's take that as the average, our baseline. This, let's say, for lack of a better word, is normal. This is normal temperature for planet Earth. If we were to then have this yellow baseline, let's compare each year. Let's take 1950. Was it a little above normal that year? Was it a little below? Let's take 1960. Let's compare each year to that baseline, that 20th century average. If we do, you'll see that all of the beginning of the 20th century was colder than that baseline. But since 1976, every year has gotten hotter and hotter and hotter. So we live in weird times. It is hotter than normal. And this is, I think, and I'm not trying to be, an old person criticizing the younger generation. But if you were born, like most students at Orange County Community College, if you were born after 1977, everything you know is warmer than average. So when you look outside, you say, "Oh, it's about normal, for a January day, or whatever." Your idea of normal is biased. You already don't know normal, and this is getting worse because 2020 three was the hottest year on record at that time. All right, by far. I mean, if you look at how high 2023 was compared to other years. But then 2024 beat that by a decent amount. Luckily, this year, all right, is not quite as hot. We don't want to break this record every year. We would like to stay normal. All right, we would like to stay the same. So 2025 was the third hottest year on planet Earth, and it just some people feel it tied with 2023. It's probably a little bit lower, but once again, that's probably minutia. We don't need to focus on this year a little hotter than last year. The key thing is the trend. There is a trend that since 1977, every year has been warmer than average. And this is getting, more and more a greater difference from the mean. The last 3 years have been the hottest 3 years on record, about 2 degrees Fahrenheit hotter than the average of say 1950 to 1980 even, which would have been even higher than this line. The 14 hottest years have all occurred since 2010. Now, when you see this, idea of 2 degrees, just to be fair, some people might say, well, 2 degrees doesn't sound like a lot. I get that. But when we look at what that does to a planet and how severe that is, and forgive me, this is my analogy that makes sense to me. I hope it makes sense to you. The Titanic was a really big boat.
Chair, please.
All right. And I'm sorry if you wouldn't mind muting. Every time I try to mute, something's going wrong on my end. So if you wouldn't mind just muting to the end, and if anyone has any questions, be happy to answer them at the end.
What the
Um,
hell?
Dorothy, I'm sorry. Could you mute yourself, Dorothy?
You can wait.
Thank you. And I'm sorry, I would mute you, but there was
No,
a glitch on my end. Um,
never mind.
so so the analogy I think of is with the Titanic. It was so big that when an iceberg was seen and said, "Ooh, this is a problem. We need to turn," you just can't turn a big boat quickly. And so that was then the problem. And all right. So Dorothy, I'm sorry, I hope this doesn't screw this up again. All right.
Yeah.
Okay, thank you, Dorothy, if you muted. Um, the same thing with a planet. A planet is huge. We humans, one species on Earth, we're changing the temperature of a planet. Sure, it's only 2 degrees so far, but you see where this line is going. I'm going to talk about the effects of that. If we get to the point where like, oh, it's hot enough, now we need to change, it will be too late. It's like that Titanic. You can't have a big boat turn on a dime when you say, oh, there's an iceberg in front of us. And the same thing um, with this huge planet changing 2 degrees. Before I get into the effects, another way that I like think about I'm sorry, Dorothy, I think I'm gonna have to try to mute you if no. I'm sorry, I've never had this problem. I clicked all right. Thank Dorothy, if you could.
Are you there, Walter?
Yeah, I am
I'm
sorry,
really
Dorothy.
sorry.
I have a glitch on my side. If you wouldn't mind just muting
I'm
on your
really sorry. The I took the audio off my computer, okay? But then the uh what is it?
So Dorothy, I'm sorry, would you just be able to just mute so that I could
Yeah,
go on? I
I'm
can't.
trying to watch it on the phone and I don't know how to mute this phone. Can you mute me because
So
the
Dorothy, I had
guys
a
are
problem.
outside from the
Okay,
computer
so Dorothy,
company.
I'm going to go on with the presentation. I'm sorry, I
Okay, thank you.
there's a problem at this end.
God damn, just tell them to turn it off. Or you know, what?
Um, I'm sorry about that, everyone. I'm doing this from home and I clicked the wrong button. I can't get out. Okay. So, what does this mean? Well, it's getting hotter, not only on land, but in the oceans. All right. So as the years get hotter, this means that the oceans are absorbing more and more heat. We can measure the surface of the ocean. So as we talk about marine life later, we'll certainly be seeing that. As the oceans get warmer and the air get warmer, ice starts to melt. Now, as we see this everywhere. So if you were to visit places where there is ice, and ice is just can be so majestic. Like, for example, if you were to go to Iceland, you would see these. Everywhere you can see glaciers retreating. All right, you can, see many places. This is where the glacier extent was in the year 1800, in the year 1900, in the year 1950, 1980. And you can just see it going further and further back. So if you were to go to Iceland, every glacier in Iceland is retreating, and 56 have disappeared. Every now and then you'll read that, they had kind of a funeral for a glacier as it finally got declassified and was no longer a glacier. Um, Not only is Iceland melting, but Greenland is melting. So here are pictures of Greenland. Greenland is currently losing about 234 billion tons of ice every year. So I'll talk about sea level in a minute. If you melt that much ice and you make it into liquid water, then obviously sea level will rise, which it has been. All right. Now, Iceland has a lot of ice. Greenland has so much more. So the fact that Greenland is melting is certainly a concern. We can see this almost anywhere. If you go to glaciers in the United States, so for example, Mount Rainier in Washington State is the largest glacier in the continental US. And then if you go at the base of it, you see it melting. Some of this is seasonal, but it continues to retreat. All right. Every glacier in the United States is retreating. Glacier National Park, probably in the not too distant future, will no longer have any glaciers in it. Antarctica is melting. Now, I have not visited Antarctica. This is just a video from Iceland showing sea ice and talking about the difference from land ice. Let me just jump to a PowerPoint thing for a second. If you were following the news last month, one of the most disturbing things, and you can look this up and you can read this many places, is that there is a huge mass of ice around Antarctica, which is stabilizing the ice on land. But this huge mass of ice, which is sometimes called the Doomsday Glacier, the name Doomsday Glacier is coming from the fact that if it were to fracture and enter the ocean, then this would now allow the land ice from Antarctica to do the same. And this would now start to greatly impact sea level. So that this ice mass is really stabilizing the oceans. This has begun to collapse in a way that we have never observed before. This is news from last month. And so I'm going to go on, but this is, sometimes it reaches like the headlines. If, for example, there was a point where from Antarctica, there was an area of ice that was 1.5 times the size of Orange County, which broke off and then became ocean water. Or we could look at how much Arctic ice is being lost, that every year you pick a month and you'll see there's just a decreasing area of ice. So here from the blue to the pink to the aqua, the amount of ice just keeps going down in the Arctic to the point where soon it may be possible to drive boats across the Arctic ocean in summer. So we are losing ice and sea level is rising, which should concern us because we have so many ports transporting so much of the supplies on Earth. For human populations, that's significant. But New York City, Miami, and so many cities are adjacent to the ocean. And as sea level rises, this will now threaten their drinking water as saline water enters the fresh water and may make it to the point where these areas really struggle to maintain, their populations because sea level is rising. Even if you don't um, live near the ocean, this can impact you because the temperature of the air, the temperature of the oceans, the movements of currents, this affects weather and now can influence the incidence of severe weather. And every year, we're seeing events of severe weather. So 2020 was the worst or the most active hurricane season on record. There are some years where you look at, look in 2021, look at the area which isn't just severe drought. This isn't just drought or moderate drought. Severe drought in orange, extreme drought in red, and exceptional drought. I mean, exceptional drought is beyond the norm of what one expects to see in any year, but you can see huge parts of the American West, month after month, can be affected by this. Now, this might change from year to year, that Utah has really bad wildfires this year, that California has really bad wildfires the next year. So one of the ways that this can be measured is just measuring the number of billion-dollar disasters. Now, obviously, the value of a dollar changes. So this has been adjusted. So if you're going to compare apples to apples, the dollar amounts have been adjusted for inflation to 2026 dollars. But if you were to say, all right, some years there are hurricanes, some years there are droughts. How does this add up? So, what is the trend of these serious disasters? And I think you can see that the trend is clear. The number of disasters keep going up. The cost of these have risen as you go from the 1980s to this. And then, all other aspects of cost too, as far as the number of deaths, etc. Now, just jumping to this, the government, used to measure this. So if you were to say, like what are the number of severe weather events? How does this compare? What is the cost? You could say, oh, this was the number in the 1980s, the 1990s, the 2000s. And so, this, taxpayer dollars pay to fix these events. There's loss of life, there's planning for future flooding, et cetera. This was important. But if you read the fine print here, you'll notice something very sad happened, and notice that this is a release from this past month. This is a note that's saying the US government will no longer be measuring billion-dollar disasters. And so as administrations change and change priorities, one of the priorities is to no longer track these from the National Oceanic and Atmospheric Administration. Now, this has been taken over by other organizations which are now going to continue measuring this. But just, that's a sad state of affairs. NOAA was one of the primary organizations which was keeping track of all of these events. With these billion-dollar disasters, obviously, there's effects depending on where you live. So, if a hurricane hits Puerto Rico, because it's so densely populated, thousands of people can end up losing their lives in the aftermath. In our area here, if there are wildfires in Canada, we get the smoke, which affects air quality here, and then affects the number of people visiting the emergency room for asthma, for heart attacks and strokes, etc. If you live out west, one of the key problems has been the drought. Once again, it's exceptional. If you were to look at Lake Mead, which is the largest reservoir in the United States, around the year 2000, it was full. All right, so where the Hoover Dam is, this was where the water level has been. But now, if you look at where it is now, all right, it has gone down hundreds of feet. So when your largest reservoir in the country drops its level by hundreds of feet, clearly this is the sign of a problem. This is where Las Vegas gets 98% of its water. Once again, these are important statistics, so you can keep track. By all means, feel free to check on this. You can go to Lake Mead levels every single year. So luckily, 2025 is not as low as 2022, but the levels are still far below. Where we would like them to be. Lake Mead is about a third full as we speak. So there are all of these effects that they can have on us as far as increased incidence of severe weather, which might cause people's houses to flood, increased heat waves, which cause people to go to um, emergency rooms for heart attack, asthma attacks, etc. Diseases can now spread into greater areas, like mosquitoes can now reach areas where they couldn't before because of changing rainfall and changing temperatures. But then this is also then affecting wildlife. So I'd like to shift gears and talk about not only will climate change dramatically impact humans, but it will also affect wildlife as well. Now, a lot of you know this, in different respects. So, for example, if you're a gardener, I'm sure you already know this because, if you're a gardener, you don't want to plant something that isn't going to grow in your area. So like, let's say you spend money for bulbs or seeds or whatever, and they just die because our area is too cold or whatever. So a gardener, before they plant, they say, what zone am I in? I'm only going to plant, zone 5 plants in zone 5. I'm not going to plant zone 8 plants in zone 5 because they're just going to die. So if you're a gardener, you say, all right, what zone am I in? This tells me what types of plants can live here. But if you look at these maps, notice these are the old zones. Here are the new zones. All right. So here, all right, we were in zone 5. Okay. But now we're in zone 6 and rapidly approaching zone 7. So if you are planting, flowers, then that, for example, if you live in Milwaukee, this was your zone, this is now your zone, but in the future, this will be your zone. So plants are changing. I use that example of a gardener because, that might, okay. Yeah, thank you. Um, because that would be something that you might relate to. But clearly, this is affecting other wildlife as well. Now, when I say temperature, temperature can mean different things. So it means, stop it. So it can mean overall temperature, but it also means when is the first frost? When is the last frost? What is the absolute cold that it gets? So it's not just temperature, which is determining where plants live, but all of these other things. And we're seeing changes in how many, days of without frost do we have. So this will affect the plants. And this then affects species because each species is adapted to specific conditions. All right. So, the reason we find, certain animals in certain places is because they like the conditions there, the temperature, the amount of rainfall. Also, then the plants that they encounter, which gives them food, etc. So, all of these species have a specific range based on that. But now, let's say that it starts, all right, stop. Let's say it starts to get warmer. Well, what that means is ranges will move farther north. So if you ask what part of the country does this animal live, as it gets warmer, the ranges of animals which used to live, say, only in Florida or only in the South, now start to occur farther north. If you look at a big mountain, if you know your mountains, you know that, you find certain plants and wildlife on the bottom, and then a little higher up, you'll find these. And there's like where the conifer forests are up here, you'll find them. Then there's the tree line. So each animal has a specific range, whether it be, you know, with its latitude or with its height on the mountain, based on, the conditions. But as the planet warms, as we change rainfall, what we're seeing is animals move. And the problem is, if you're going up a mountain, after a certain point, you have nowhere else to go. You can't go any higher. Or if your forests tend to move farther north into Canada, you may reach an area where you've lost more range than you've gained. So this is affecting um, wildlife. Before I get back to the ones on land, I'd like to just kind of talk about the ones in the ocean for just a second. One of the things that I realized in a different way when I visited the Galapagos was the idea of El Nino and La Nina. I know it's a thing. I just didn't really appreciate how much of a thing. But if you go to the Galapagos, not only will you love, like swimming with these green sea turtles, but notice the current. And it's kind of funny, like I felt like I had a bond with these sea turtles because I'm swimming against the current. It was a little hard to swim against it. And the sea turtle was swimming against the current. So here we are swimming next to each other. It's like, hey, how about this current, right? So anyway, we had this bond. Um, but this current only exists in certain years, and that cycle of El Nino and La Nina affects that. This current is important because this brings all of the nutrients up from Antarctica. And notice how green it is with all of the algae. So because of the current, because the algae bloom, now we have all these fish blooming. Now the sea turtles can eat, marine iguanas can eat. The marine life loves this current. The land life doesn't, because during the years where this current is flowing, there's less rainfall. So then the land all gets dry and all of the, plants turn brown for a couple of years. Because of climate change, El Nino events, which will cause these currents to shift, which will affect the land life, they are becoming more frequent and more severe. So climate change is affecting the marine life around the Galapagos because it's changing the currents which nourish the marine life. It will also then change the land life because now the land is going to get more rain. So the currents are shifting. The temperature is shifting, as I mentioned. So the temperatures are getting hotter. And because there's more and more carbon dioxide in the air, carbon dioxide dissolves in the ocean and becomes carbonic acid. So if you live in the ocean, your ocean is changing. The currents are changing. The temperature is changing. It's going up. The acidity is going up. So that's just a lot of stress. A lot of things are changing at once. And one of the organisms that doesn't like change are the corals. Coral reefs are dying. All right, so this is a beautiful, healthy reef. Oh, look at that reef. Look at the fish. It is a pleasure to see that much diversity. But all over the world, all right, the Caribbean is bad. I have heard that Southeast Asia is worse. More and more coral is looking like this. It's bleaching. You see that it's become white because the coral animals, the temperature is having a negative effect on them, the severe storms negatively affecting them, the acidity of the ocean negatively affecting them. And so the corals are dying. With them then comes all of the fish that depend on the corals. And then with them, all of the animals that depend on the fish. So we humans are changing so much in such a short period of time. You saw that rapid increase of the gases, the temperatures, etc. That's a lot of stress as these natural conditions for marine life all suddenly change. Jumping back to on land, the same thing could be said about every single ecosystem. So let's go to desert ecosystems. Out west, so this is Baja, California in Mexico, but then the same is true of the southwest of the United States. It has become drier and drier and drier. You saw all the years where there was exceptional drought. That being said, there are then years where the rainfall is in excess because of the number of severe storms. So in Baja California, if you were to look at this desert, and this is a desert, it looks pretty green. All right. And all of the people I met who were there, they were saying this is as green, about as green as they had ever seen this. This is not normal. All right. So for recent years, it's been super dry, super dry, super dry. Obviously, a stress to plants and animals. But now all of a sudden in this year, it's they've had far greater rain than they usually do. Um, Once again, I'm just making the point that things are changing. And as things change, there may be organisms which benefit from the change, and then others which then struggle. This is just different from what it used to be. So the deserts out west are changing. Costa Rica's dry forest is changing. Once again, Costa Rica has been getting more rain than it has in the past. And so therefore it's lush and green. But if you look at all of these cacti, they are adapted to this part of the world because these tropical dry forests are used to not getting as much rain. Now that they're getting more rain, those cacti, which are adapted to dry climates, now will have to compete with new plant species because the wetter conditions allow more different species to occur. In our area, we have some wet years, we have some dry years. Uh, the last two summers have been really wet. I'm sorry, have been really dry. So here were some swans from 2 years ago, where they started off with 6 baby swans and ended with one. This past year, they started with 8 and ended with 3. So in the past 2 years, most of the baby swans have died and not made it to adulthood. And one of the reasons, undoubtedly, is look at this. This is supposed to be wet. This is 6.5 station sanctuary near Goshen. But in the past 2 years, we've had such dry temperatures that this is a stress. Predators can get at them more easily. They're hot. They can't cool themselves in water. So all over the world, species are experiencing new changing climatic conditions. And this is affecting them in so many ways. Okay. So for example, you might see in Orange County a little blue heron. We've seen a couple in the past couple of years. This is a Florida bird. All right. So that's unusual to see them here. And as temperatures change, we expect to see some species shift their distribution. Red-bellied woodpeckers, I'm used to seeing those. They're fairly standard in our area. But their species name is carolinensis because this bird was more typically seen in the Carolinas about 50 years ago. But it has been getting warmer and they've expanded their range northwards. The same could be said of Carolina wrens. Carolina wrens, all right, they usually did not live here during winter. It was too cold. But winters have been milder, and so you are more likely to see a Carolina wren than you would have been in the past. All right, when I was a kid, black vultures were what you saw if your family took you to Disney. All right, you didn't see them in the Northeast US, but black vultures are here to stay now because it's gotten warmer. So we have already seen species shift their ranges. A lot of birds that we see in Orange County, they really weren't seen not that long ago. And there are some other species like the little blue heron that I had mentioned, where you say, ooh, we're starting to see this more and more. Is this the beginning of a trend? And if you were to look at what Audubon uh, is concerned about. The Audubon Society, the National, which I'll mention again in a little bit, they are very concerned about this. So they are saying, look, we are measuring habitats. Like there's certain northern forests, the conifer forest that you get in certain areas. That's a type of habitat where certain animals, this is where they breed. All right, or the savannas are here, or the grasslands, et cetera. And we're seeing changes in the distribution of these um, these habitats. And so based on these changes that they're seeing, the Audubon Society is trying to measure how this will affect some species because some species may benefit and expand their ranges, but other ones may be more threatened. So, for example, this sparrow, which does pass through Orange County during migration season, a lot of its populations live in salt marshes. But if sea level rises, that's going to take away a lot of their habitat. So it is expected that they will be negatively impacted by climate change. Dark-eyed juncos, all right, these are sparrows, which we have in our area now. But if you ask, where do they breed? They breed in northern forest. So this is Mount Washington, this video from this past summer, and this is the tree line. So this is the highest mountain east of the Mississippi River. So these juncos not only live in Orange County in the winter when it's cold, they live in pretty harsh environments like on the tops of mountains. But as I pointed out, the mountains are changing. And so it is expected that that will put pressure on these birds and any other birds that breeds in conifer forest, like in Canada, the Adirondacks, etc. So this bird that we have now in winter here in Orange County, it's going to breed in these conifer forests. But the conifer forests are moving farther northward as climate changes. They will have less area to breed. And we could go into, I'll just go through maybe two more examples. If you shift the time when plants bloom, when insects come out, then birds coming back from migration, they're confused. Like, when do you breed? When do you lay eggs? One of the threats that bobolinks face is that humans like to make hay for lots of reasons. If you're going to keep horses or cows, you make hay. But the problem is, if you are going to make hay out of this field, environmentalists would ask, could you please do it after their nesting time is done? Please do not, cut down all of the grass when their nests are on the ground because you'll kill a lot of birds in the process. Well, if you're shifting the temperature, then you might move the time when the plants are blooming and would be ready to make hay out of to make them earlier so that now people who used to give enough time to the birds to nest before cutting down a field would now take more birds as accidental casualties here. One more example of this. One of the birds which we are losing is the golden-winged warbler. One of the reasons is not only are habitats changing, but as habitats change, there is another warbler called the blue-winged warbler whose range is moving farther north, which interbreeds with golden wings. So the blue-winged warbler is starting to replace the golden wing because of the shift in habitats. Now, one example, I'll just try to, this is my last big point before I start to pull all the things together, is let's say there are little things that could make your day worse. Like, I don't know, your cable goes out, or your car's check engine light comes on, or your boss at your job, is mean, or there's, an expense that you have to pay, your washing machine breaks, or, each of these in and of themselves are manageable. But if they all happen on the same day, all right, there's ice, and you hit a patch of ice and now, you damage your car. If all of these happen in the same day, you're having a really bad day. And wildlife is facing that. All right, because the temperature is changing, the amount of rainfall is changing, their habitat for breeding is shrinking. All of these things are happening, and now the bugs are changing. So, why are all of these trees in Colorado dead? The answer is because the mountain pine beetle is able to eat more trees and thus cause the death of trees than it used to. Why? Because winters aren't as cold. It used to be the cold of Colorado winters that would kill these insects and keep their populations in check. But as winters get milder, then you don't have the same die off of the bugs. And now this is going to affect the trees and all of the things that depend on the trees. Now, that was one example, but spotted lanternflies are a problem. But as we get warmer temperatures, they're expected to get worse. Excuse me. Japanese knotweed, that's an invasive species in our area. So if you look along the Delaware, all those tall plants, they shouldn't be there. That's all Japanese knotweed. That's an invasive species. They should not be here. With climate change, we expect that this species will thrive, all right, that they will like the warmer temperatures, and we will have more of those. The spongy moths, which were formerly known as gypsy moths, we expect that as winters get milder, not as many of them will die in winter. They will get worse. Water chestnut is the invasive plant that I like the least because it can really just take over a wetland and really detract. I mean, look at how water chestnut has covered this, choking the oxygen, the sunlight, just horrible, the effects that it has on all of the wildlife that depend on this wetland. The warmer temperatures, the more severe droughts, which lower water level, will make it easier for this invasive species to thrive. So getting back to like having a really bad day. Now there's all of these invasive species which are changing habitats. So many wildlife are having really bad days because all of this is happening at once. So climate change is likely to have significant impacts on human populations, but also significant impacts on wildlife. Now, we can hope to minimize this. So, just one thing that you can do, for example, is the next time you plan a meal, all right, certain meals produce more carbon dioxide than others. So if you eat a lot of meat, especially if you eat a lot of beef, there is more greenhouse gas associated with that than there otherwise would be. So if you just picked one day of the week and had a meatless Monday, or you were vegetarian, I'm a vegetarian, then that would cut down on the amount of carbon dioxide that you could produce. If the next time an appliance goes, you get a high efficiency appliance, then that would reduce carbon emissions. If you insulated your house better, if you got a more fuel efficient a car. Many of these ultimately pay for themselves. So in the end, you have actually saved yourself money in addition to helping the environment. When it comes to wildlife, we're actually in a season right now where the Audubon Society, the National Audubon Society, hosts a climate watch series of studies where they're trying to measure bird populations. If you contact an Audubon Society near you, you could volunteer for Climate Watch and go out and maybe look for bluebirds at certain stations. And what it is you go here for 5 minutes, look for bluebirds, then you go to your next spot, look for bluebirds for 5 minutes, and you enter the data. And this helps Audubon determine where they think species will be changing the range and migrating to. And this is important as individuals look at like, well, where should we try to preserve land and what species do we think is in greatest danger. So you could volunteer for these things. So there is a lot that you could do individually, but not to minimize your impact at any point. But then again, they're just things that are bigger than you, like the Hoover Dam. All right, that's not something that an individual does. It was the federal government that did the Hoover Dam. That's just such a big project. And so if this is important to you, especially we are in an election year, if you were to let your representatives know that this is important to you, because here you can see the National Centers for Environmental Education and NOAA is changing what it monitors based on shifts in political thinking. And so, whatever you value, whether it be about the environment or anything. Obviously, you have your chance to make that known to your politicians and help to elect individuals who reflect your values. And hopefully that can make a change as well. So this was an overview just of kind of, the causes of climate change and global warming and the effects that it can have on both humans and wildlife. I really thank you for joining. It's been great to have you. And I'm sorry that just me being an old man, there was a button here that I struggled with for a second, so I'm sorry about that. And if you're interested, we'll be doing a series of talks all throughout the semester and recording them if you were unable to make any of them. And like I said, if you enjoy this, or if you said like, this is a topic that interests me, there are all of these organizations in our area, which are made of people like you, which would love to have your membership, which would love to see you at their presentations, on their field trips, etc. So I would encourage you to reach out to them. So that's about it for tonight. But did anybody have any questions? We can certainly now just kind of field the floor, everyone take their turns. But once again, thank you all for coming, and I hope you stay safe with the snow and the roads. Feel free to shout out any questions that you have.
Sure.
Yeah,
Thanks,
hi.
class. And you said that you'd like a summary of what we learned tonight. And how would I go about submitting that for you?
You can just send it as an email.
Okay, great. Thank you so much.
Thank you, Amy. Anybody else? Any questions, any thoughts, any things you'd like to share?
Walter, it's
Yes.
Dorothy. Um,
Hi, Dorothy.
yeah, I'm really sorry about before. The Spectrum people were in my driveway because there was an outage and with our neighbor, and they came back unexpectedly, and I was trying to get you on my phone, and it was just a mess. So I'm sorry I interrupted.